This is the second video for worksheet 9.8. These are all proofs, and I'm going to start with a simple one in part A, and then I'll do one more complex one in part G. So in part A, and in all of these, we're using the 6 trig ratios and variations on the Pythagorean identity to construct each proof. So we're substituting what each identity or ratio is equivalent to. So 1 over secant theta equals cosine theta. There's different ways you can approach this. One way of approaching it is to just rewrite the equation by cross multiplying. So secant theta multiplied by cosine theta equals 1 multiplied by 1. If we rewrite secant theta, we know secant is the reciprocal of cosine. So 1 over the cosine of theta times cosine theta equals 1. Here we can show that cosine theta and cosine theta cross out, so 1 is equal to 1. Let's also look at the last one here, which is more complex. We have sine theta plus cosine theta squared. We know that when we square something, we're multiplying it times itself. So this squared would be sine squared theta plus sine cosine, and sine cosine is 2 sine theta cosine theta plus cosine squared theta. We also have this expression, sine theta minus cosine theta squared. So we're adding sine theta minus cosine theta times itself. So distributive property there will give us sine squared theta. We have a negative cosine sine and another negative cosine sine, so that's negative 2 cosine theta sine theta, and then plus cosine squared theta. So let's look for like terms. So 2 sine theta cosine theta and negative 2 sine theta cosine theta can cancel. So we then have 2 of the sine squared theta, and we have 2 of the cosine squared theta also. We're trying to prove that this is equal to 2. Here, if we factor out a 2, we can rewrite it like this, and the Pythagorean identity tells us that sine squared plus cosine squared is equal to 1. 2 times 1 equals 2. And in general, on these proofs, there may be more than one approach for how you show the steps, just like in a geometry proof. So if you showed the steps slightly differently than somebody else, there are multiple ways to do it correctly.